All right, welcome to another deep dive today. We're going to be talking about something that's, I think, pretty fundamental to good software architecture and design, and that's the proxy design pattern.
Hmm.
If you're going for those senior software engineering roles, you're going to be expected to have a good grasp on this and really understand the nuances of it and when to apply it.
Absolutely. It's one of those core design patterns that you're likely to encounter in real-world applications and definitely in technical interviews. So getting comfortable with it, knowing when it's appropriate, and being able to discuss its variations is really valuable.
Yeah, for sure. So let's just jump right in, shall we? I mean, what is this proxy pattern all about at its core? Like, if you had to sum it up.
Well, I guess the simplest way to put it is, it's all about providing a stand-in for another object. You're essentially creating a controlled way to access the real object, maybe delaying its creation, adding some extra checks, or handling communication with something in a different location, all without the client knowing the difference.
Okay, so like a surrogate. I've heard that term used too, right?
Yeah, that's another way to think about it. You're creating a surrogate or a placeholder that takes on the responsibility of interacting with the real object.
Okay, so that makes sense in theory, but help me ground this a bit with an example, maybe something that, a senior engineer might run into.
Okay, sure. Imagine you're working on a document editor, something fairly complex. And this editor, it needs to handle documents with like tons of images embedded in them, high resolution stuff.
Yeah, definitely. That's pretty standard these days.
Right. But now think about what happens when someone tries to open one of these documents. If you were to load all those images right away, up front, you'd probably end up with a really slow and unresponsive application.
Oh, absolutely. I mean, users would hate that, right? Like waiting forever for a document to open just because it's loading a bunch of images they might not even need to see right away.
Exactly. And that's where a proxy can come in really handy.
Okay, so walk me through how the proxy would solve this. Like specifically, what would you do with those images?
Well, instead of directly instantiating those image objects right away, you could introduce an image proxy.
Okay.
This proxy, it would essentially act as a stand-in for the real image, but it's a very lightweight stand-in. It knows an image should be there, but it doesn't actually load the full image data until it absolutely has to.
So like until the user actually scrolls down to the part of the document where that image is visible or something.
Yeah, exactly. Or maybe until the user specifically requests to view that image. The point is, the proxy delays the loading, the heavy lifting, until it's absolutely necessary. This lazy initialization is a key concept here. It only creates the real memory-intensive image object when it's actually needed.
That's clever. So to the document editor, it's like, yep, there's an image here, but behind the scenes, it's just a placeholder until the last possible moment.
Right. And even then, the proxy doesn't just vanish. Once it creates that real image object, it keeps a reference to it.
Yeah.
So any future requests for that image, like to redraw it or get its properties, can be passed directly to the real image.
Okay, so the proxy kind of manages the whole life cycle of that image object in a way.
Exactly. In the beginning, the proxy might just be holding on to, say, the file name of the image on disk.
Right, as a way to locate it when it's needed. So what would you say is like the core takeaway here for someone thinking about performance? Like, how would you sum up this idea of a virtual proxy?
I'd say the key is you delay the instantiation of expensive objects to improve startup time and make the application more responsive. You don't pay the cost of loading something until you actually need it.
Makes perfect sense. So we've got this idea of a proxy as a stand-in, a way to control access. But what about the structure? How does this all actually fit together from like a design pattern perspective?
Well, if you look at the typical UML diagram for the proxy pattern, you'll see four main participants: the client, the subject interface, the real subject, and the proxy itself.
Okay, so the client is straightforward, right? That's just the part of the code that wants to work with the object, like our document editor in this case.
Yeah, exactly. The client is the one that needs to use the object, but it doesn't need to know about the specifics of whether it's dealing with the real object or a proxy.
And that's where the subject interface comes in, right?
That's right. The subject interface defines the common set of operations that both the real object and the proxy must support. It's like a contract. So for our image example, it would define things like being able to draw the image, get its size, maybe get its file path, that sort of thing.
So both the real image and the proxy promise to be able to do these things.
Exactly. Then you have the real subject, which is the actual object that does the real work. In our case, that would be the image class with all its loading and rendering logic.
All right, so the real deal. And then finally, the proxy itself.
Right. The proxy also implements the subject interface, which is key because it means the client can treat the proxy just like the real thing.
Okay, so the client doesn't even have to know it's working with a proxy.
Exactly. The proxy holds a reference to the real subject and decides what to do when the client calls a method on it. Like in our example, if the client calls draw on the image proxy, the proxy would then go and create the real image object if it hasn't already, and then delegate the draw call to the real image.
So there's this extra step where the proxy can decide what to do and when to actually involve the real subject.
Right. And that's where a lot of the power of the proxy pattern lies. It introduces this layer of indirection that allows you to control access to the real subject. It decouples the client from the real subject, allowing you to do things like lazy initialization, access control, logging, or even caching, all without the client being any the wiser.
Interesting. So the proxy is kind of like a middleman, a gatekeeper.
Yeah, you could think of it that way. It intercepts requests and decides how to handle them. And you can visualize this relationship with a runtime object diagram.
Oh, right, those diagrams. How would that look for a proxy?
You would typically have an instance of the client interacting with an instance of the proxy. Inside the proxy, there would be an attribute, maybe called real subject, which would initially be empty.
Okay, so no real subject yet, just the proxy standing in.
Right. But then at some point, the proxy might create the real subject and store a reference to it in that real subject attribute. This really shows how the client only ever talks to the proxy, and the proxy handles the relationship with the real subject.
So it's all about that controlled access, the ability to add extra functionality without messing with the real subject itself.
Exactly. And that's what makes the proxy pattern so versatile and applicable in so many different situations.
So speaking of those different situations, we've talked about this virtual proxy with the image example. But what are some other common scenarios where this pattern is really useful?
Oh, there are quite a few. We've got the remote proxy, the protection proxy, and the smart reference, just to name a few. Understanding these different types of proxies is key for those senior level interviews.
Okay, so let's take them one by one. What's a remote proxy all about?
A remote proxy is essentially a local representative for an object that lives somewhere else, like on a different server or in a different process. It hides the complexity of network communication from the client.
So I can work with an object that's actually on another machine as if it were right here.
Exactly. The remote proxy handles all the marshaling and unmarshaling of data, the network calls, all that stuff. The client just interacts with the proxy as if it were the real object.
That's really powerful, especially with, distributed systems and microservices being so prevalent these days.
Absolutely. In a microservices architecture, you often have services running on different machines that need to communicate with each other. A remote proxy can make this communication much simpler and more transparent.
So instead of writing a bunch of low-level networking code, I can just work with a proxy that abstracts all that away. What's the main benefit there for someone building a distributed system?
The main benefit is that the remote proxy simplifies the development and maintenance of distributed applications. You don't have to worry about the nitty-gritty of network protocols and communication. You just interact with the proxy as if it were a local object.
Right, that's a huge win. So we've got remote proxies for handling objects in different locations. What about protection proxies? Those sound kind of interesting.
Protection proxies are all about security. They control access to the real subject based on the client's permissions or roles.
Okay, so like a gatekeeper that checks your ID before letting you in.
Yeah, exactly. Imagine you have some sensitive data or functionality that you only want certain users to access. A protection proxy can enforce those rules.
So for example, if I have a user object with sensitive information, I could use a protection proxy to ensure that only administrators can modify certain attributes.
Exactly. Or maybe you have an operation that should only be available to users with a specific role. The protection proxy can check the user's role before allowing the operation to proceed.
That's really powerful for, building secure applications. So the protection proxy basically adds a layer of security without having to modify the real subject itself. What would you say is the biggest advantage of this approach?
The biggest advantage is that you can enforce security and access control in a centralized way. You don't have to scatter security checks throughout your code base. You can handle it all within the protection proxy.
Right, so it's a nice separation of concerns, making the code more maintainable and easier to reason about. And then finally, we have these smart references. What are those all about?
Smart references are kind of like souped-up pointers. They act as a replacement for a regular pointer, and perform additional actions whenever the object they point to is accessed.
Okay, that sounds intriguing. What kind of additional actions are we talking about?
It could be things like reference counting for automatic memory management. When the last smart reference pointing to an object goes away, the object can automatically delete itself, preventing memory leaks.
Ah, right. That's the idea behind smart pointers in C++ DOL. So it's kind of like having a pointer that's aware of its own life cycle and helps manage the object it points to.
Exactly. And it can go beyond just memory management. Smart references can also handle things like lazy loading of objects from a database or file system.
Hmm. Okay. So instead of loading the object right away, I could have a smart reference that only loads it from the database when it's first accessed.
Precisely. It can also handle things like locking for concurrent access in a multi-threaded environment. So before allowing access to the object, the smart reference can check if it's already locked and prevent race conditions.
Wow. So smart references are like these little powerhouses that take care of all sorts of important tasks behind the scenes. How would you sum up their main purpose for a developer?
Smart references automate resource management and enhance data integrity. They take care of things like memory allocation, object persistence, and concurrency control, so the developer doesn't have to handle those details manually.
So they reduce the burden on the developer and make the code more robust and reliable. That's a big win. Now, we've talked a lot about the benefits of the proxy pattern, but are there any downsides or potential drawbacks to consider?
Well, like any design pattern, the proxy pattern introduces a level of indirection. This means that every request from the client now has to go through the proxy before reaching the real object.
So there's a slight overhead involved.
Yes, but in most cases, this overhead is negligible compared to the benefits gained. It's something to be aware of, especially in performance-critical applications, but generally it's not a major concern. The advantages often outweigh the costs.
Right. I mean, we've seen how a remote proxy can hide the complexity of network communication, how a virtual proxy can improve performance by delaying object creation, and how protection proxies and smart references can handle security and resource management. So those benefits seem pretty substantial.
They are. And there's another interesting optimization we briefly mentioned, copy on write.
Oh yeah, that one. Remind me how that works again.
It's a technique where a proxy can delay the actual copying of an object until it's actually modified.
Ah, right. So if I have a large object and I want to create a copy, I can use a proxy to create a lightweight copy initially and only do the full copy if the object is actually changed.
Exactly. The proxy would use reference counting to track how many clients are using the object and only perform the full copy when a modification is made. This can save a lot of memory and processing time, especially for large objects.
That's a clever optimization. Now, on the practical side, how would you actually go about implementing these proxies? Like, are there different techniques or approaches?
Yeah, definitely. There are a few common ways to implement proxies. In C++A, for example, you could use operator overloading.
Operator overloading. How would that work for a proxy?
You could overload the member access operators in C++A, specifically operator-an operator. This allows you to create a proxy object that syntactically behaves like a pointer to the real object.
So from the client's perspective, they're just using a pointer, but behind the scenes, it's actually a proxy object.
Exactly. The proxy can then intercept any access to the object and perform whatever actions are necessary. The downside is that this approach doesn't give the proxy much information about the specific operation being called. It just knows that the object is being accessed.
I see. So it's a bit limited in that sense. Are there other ways to implement proxies that might give you more control?
Yeah, some languages like Smalltalk have mechanisms for handling messages that an object doesn't understand. For instance, Smalltalk has this thing called does not understand.
Does not understand. That sounds interesting.
Basically, when an object in Smalltalk receives a message that it doesn't have a corresponding method for, it triggers this doesn't understand method. A proxy class can redefine this method to forward any unknown messages to its subject.
Ah, that's clever. So the proxy acts as a catch-all for any messages that the real object doesn't handle.
Exactly. The proxy would typically have a way to access the real subject, maybe through a real subject method, and then use something like perform.withArguments to forward the original message and its arguments to the real subject.
That sounds pretty dynamic. Are there any downsides to this approach?
It can have some performance implications because the method lookup happens at runtime. Also, it might not handle certain special messages, like those related to object identity, in the way you might expect.
I see. So there are trade-offs to consider.
Yeah.
And you mentioned that for protection proxies, this approach is particularly useful, right?
Yes, a protection proxy could use this does not understand mechanism to check a set of allowed messages before forwarding them. So if the received message is not in the allowed set, the proxy can block it.
Right, so it acts as a security guard, only letting through authorized messages. Makes sense. Now, does a proxy always need to know the concrete type of the real object it represents?
Not necessarily. If the client interacts with the subject only through the abstract subject interface, then the proxy doesn't need to know the concrete type. This is good for flexibility and loose coupling.
Okay, so the proxy can be more generic in that case, but are there situations where the proxy does need to know the concrete type?
Yes, definitely. Like with a virtual proxy, for example. If the proxy is responsible for creating the real object on demand, then it needs to know what concrete class to instantiate.
Right, that makes sense. And what about when the real object isn't in memory yet? Like in our image example where the image is still on disk.
That's a good point. In those cases, the proxy needs a way to refer to the object that's independent of its memory location. So it might use something like a file name or a database key as a reference.
So it needs some sort of unique identifier to locate and load the object when needed. Okay, so we've covered a lot of ground here. We've talked about remote proxies, virtual proxies, protection proxies, and smart references. These seem to be like the main variations of the proxy pattern.
Yeah, those are the most common ones, and they cover a wide range of use cases.
Now, I know some languages, like Java, have this built-in support for dynamic proxies. Can you tell me a bit more about that?
Yeah, it's up to you to implement the invoke method and define the logic for what the proxy should do. You can perform any actions you want before, during, or after the actual method call on the real object.
That sounds incredibly flexible. So I could use this to log all method calls, for example.
Exactly. Or you could check security permissions before allowing the method to proceed. You have full control over the behavior of the proxy.
I've heard this geeky matchmaking in the object fill example used to illustrate dynamic proxies. Can you walk me through that?
Sure. Imagine you have a person interface with methods to get and set attributes like name, gender, interests, and even a geek rating.
Okay, like a dating profile or something.
Right. You also have a concrete class, maybe personable, that actually stores this data. Now, you don't want users to be able to change their own geek rating or modify other people's information, right?
Yeah, that makes sense.
So you could create two different dynamic proxies, one for the owner of the profile and one for non-owners. Each proxy would use a different invocation handler.
Okay, so the owner invocation handler would allow access to everything except the set geek rating method.
Exactly. And the non-owner invocation handler might only allow setting the geek rating, but restrict changing other personal details.
So each invocation handler enforces a different set of rules.
Right. And the beauty is that you can implement any logic you want within the invoke method.
Yeah.
You examine the method being called, maybe using its name, and then decide what to do based on the context.
So if someone tries to do something they're not allowed to do, the invocation handler can either block the call, throw an exception, or perform some other action.
Exactly. It's incredibly flexible, and Java makes it really easy to create these dynamic proxies.
How so?
There's a static method in the proxy class called newProxyInstance. You pass in the class loader, the interfaces you want the proxy to implement, and your invocation handler. Java then creates a new proxy object that implements those interfaces and forwards all method calls to your invocation handler.
So I would have, say, a getOwnerProxy method that takes a person object, creates an owner invocation handler, and then uses proxy.newProxyInstance to create the proxy.
Precisely. And you'd have a similar method for creating the non-owner proxy.
So is it like the invocation handler is the actual proxy object?
Not quite. The invocation handler is just an intermediary that handles the method calls. The actual proxy object is created by Java dynamically.
Okay, so Java creates this proxy on the fly based on the interfaces and the invocation handler I provide.
Yes, and you can even check if an object is a dynamic proxy using the proxy.isAProxyClass method. There are some restrictions on the interfaces you can use. For example, you can only proxy interfaces, and they all have to be from the same package if they're not public. Also, they can't have conflicting method signatures.
Right, makes sense. Dynamic proxies seem like a really powerful tool for handling cross-cutting concerns and implementing things like security policies without modifying the core objects themselves.
They are, and they're especially valuable when you need to apply the same kind of logic to multiple classes.
Now, as we wrap up our discussion on the proxy pattern, it's good to understand how it relates to other patterns, right? Like, how is it different from an adapter, for example?
That's a good point. People sometimes get them mixed up. The key difference is that an adapter provides a different interface to an existing object. A proxy, on the other hand, provides the same interface as its subject. Although a protection proxy might effectively restrict certain methods, the interface itself remains unchanged.
So an adapter is for changing interfaces, while a proxy is for controlling access or adding behavior.
Exactly. And how about the decorator pattern?
Right, the decorator. That one also seems similar because it wraps an object to add functionality. How do we distinguish between a proxy and a decorator?
The main difference is in their intent. A decorator focuses on dynamically adding responsibilities to an object without using inheritance. It's about enhancing the object's capabilities. A proxy, on the other hand, is primarily about controlling access to the object or managing its lifecycle.
So a decorator might add new methods or modify existing ones to add functionality, while a proxy is more about intercepting method calls and deciding what to do with them.
Yeah, that's a good way to think about it. Even though their implementations can sometimes look similar, they solve different problems.
This has been a great deep dive into the proxy pattern. Any final thoughts for our listeners who are preparing for those senior-level interviews?
I'd say the key takeaway is that the proxy pattern is a powerful tool for controlling access to objects. It can solve a variety of problems like performance optimization, remote communication, security, and resource management. Being able to recognize those problems and explain how the proxy pattern can address them is crucial for those senior-level discussions.
Absolutely. Knowing its variations, the trade-offs involved, and how to implement it will really demonstrate your understanding of object-oriented design principles.
And as you prepare, think about how you could apply the proxy pattern to real-world problems. Maybe there's a project you worked on where it could have been useful. Or maybe you can anticipate situations where it would be a good fit. Thinking about concrete examples will help solidify your understanding and make you a stronger candidate.
That's excellent advice. Thanks so much for taking us through this deep dive. It's been really insightful.
My pleasure.
And to our listeners, keep diving deep into those design patterns. They're essential tools for any senior software engineer.